programming terms that aren't really. So today we're going to talk about metaprogramming. So that's a pretty complicated sounding thing, but really all it means is a program that creates another program. Metaprogramming. Pretty simple. So here's like a really kind of fun example of a program that creates another program. We have our main function. It writes to the console a string. This is just a big string. And that string is itself a program that you could compile and run. Right? If we run this, the output is valid C# source code that we could compile and run. That's pretty much the most basic type of metaprogramming, kind of where you do it by hand. And this might seem silly, but people actually do stuff like this. For instance, a lot of people who use the Go programming language, which has no generics, they'll write a program. They can take in Go source code and then output a new Go source code to basically implement generics for themselves. And there's lots of other uses where you could do something like this, right? Usually it's to save yourself some typing. You might have something you want to code and you imagine, oh man, I'm going to have to write almost the same thing like 100 times to do what I want to do. So instead, you write a program that generates that program for you. Right, so that's one way people do metaprogramming. Another type of metaprogramming is generics. So as an example, C# has generics, and there is a lot of collections built in that uses them. So if we say using system.collections.generic, we can make, for instance, a list of some type. Right? So we see list T there. T is a placeholder. That means list can be any type we want, and we just have to tell it. Right? So we can do list T int. So now we get a list of ints. Or we can do float. And we get a list of floats. So why is this metaprogramming? So the reason why is because whenever you do this, as soon as you say list of int, right, the compiler goes through and creates a new list, basically new list code that operates on ints. And if you create a list of floats, the compiler creates a new set of list code that operates on floats. So at compile time, sort of new code is being generated for you. And this is just sort of an easier way of doing metaprogramming. You don't always think of it like that. But what's happening behind the scenes is every type that you use list with, the compiler generates a new list that you can use. So that's another kind of metaprogramming. And some languages have generics or something like it, and some don't. Those are both examples. Our original example, where we had the big string, and generics are both examples of compile time metaprogramming. Some languages allow for runtime metaprogramming, like Lisps. We won't get into that today, but that can be cool too. So let's flip over to the C language for a little bit. And we'll talk about macros. So some languages have macros. And a macro is basically a mechanism where you can replace, you can do like substitutions at compile time. C# does not have a macro system, but C does, Rust does, Nim does. There's a lot of languages that have some type of macro facility. So I'll just show some examples of how you can use macros to make your life easier sometimes. So something I do in C a lot is play with SIMD intrinsics. And SIMD intrinsics have this kind of crazy syntax, right? Like these are really noisy function signatures. So a really basic thing you might want to do with macros is kind of get rid of this noise. Make your own kind of API that you can use But you don't want any kind of runtime overhead, right? You don't want to actually write like functions that call these functions and hope they get inlined. You don't want to deal with that. You want to be sure that these things have no performance overhead if you're going to make a new wrapper for these. And so macros are a good way to do that. So I'll show an example. So one of the functions we're using here is set, this set function. This means we're setting floating point, single precision floating point values into a SIMD value, SIM128. Well, let's just say we want to make that simpler. All right, we'll just call it set. And set will take in 4 things. And we want the result of that to be like this. And that would let us change these to just set. So what is actually happening here? So this macro syntax, what it says is we're going to have some name called set that's going to take in 4 things. And then it will then replace these A, B, C, D here with whatever you've passed in here, right? So if we call set A, B, C, D, it's going to replace it. So this will just translate to set PS 2.0 minus 3.0, etc. Now the trick here is that these are not variables in the normal C sense. Like you could put anything in here. Right, you can put in hello, and this would then be a compile time error, right? Because this eventually gets turned into set with a string passed into it, and it's no good. And there's other complications, like you can pass in, parens and so on, and you do have to do some special things actually sometimes, like wrapping things in parens in C to make sure this always works. But we're not going to mess with that today. So we can do this really quickly for all the complex SIMD functions we're using. So we can do, this is a compare less than. So we can just say less than AB, and then that will be compare less than PS AB. Now this becomes less than. And we're doing an or, an and not, and an and. So let's do all those real quick. These are bitwise ors and ands on floating point values. Then and not. And I think that's it. So now we can do we're also doing a set 1. So set 1 does the same thing as set, except sets all of SIMD values to the 1 value you pass in. So let's do set 1. So now we're going to use set 1. Like so. Okay, so a nice thing we've done here is we've made our code more readable to us, maybe, and we have less typing to do. A bad thing that we've done here is if someone's actually used to seeing SIMD intrinsics and they come into your code where you've made up your own little API here, they may not be familiar with it, right? They might see less than and be like, well, which less than is this? Is this the floating point less than or the integer less than? Is it an AVX2 less than or an SSE2 less than? So something like this can be really nice for sure if it's just your personal project, so you can do whatever you want to make your life easier. But if you're working with other people, you might think about not doing this unless it gets you a really big win, right? Because other people then have to learn your set of macros that you've made. And that's a general idea that's true in any language you're working with macros, right? You can make your own sort of domain-specific language with metaprogramming, but then other people have to learn that domain-specific language. So you have to make the choice about whether you're getting enough benefit for adding that confusion. And you also have to consider that when you start doing metaprogramming, you make compile times longer. Something like this is going to be very minimal impact, but if you get into like really complicated Rust macros or doing crazy things with generics, compile times can get pretty big. So you need to think again, is it worth that cost you're paying, right? Because your compiler has more work to do anytime it's generating a new program from your program. So let's show a more interesting use case of macros, because all we've done here is just make our names shorter. Maybe that's not worth it. But there are some nicer things we can get out of it. For instance, this operation here, what we're doing is a special way of doing conditional logic with SIMD instructions. So these all operate on multiple values at the same time. And I want to get one result if t is less than 0, and another result if t is greater than 0. And you can't use an actual branch because there's multiple values going on with a single operation. So what this mess does, the or and not and, is it selects the individual values we want based on the conditional mask. We create a mask here, and we select the values out of n that we want based on. Oh, this should actually be t, I think. Yeah, this should be t. Right, so we're either getting our values out of t or out of n, depending on the conditional. All right, common thing you do with SIMD. So maybe we don't want this mess. Also, if we have newer SIMD instructions, so like a newer CPU, these are SSE, these are just the headers where these intrinsics come from. So if we have SSE41, there is a single function for this that we can call instead, called blend. Right, so we could call instead of this, we could call blend v ps t n conditional. Right, and that's faster and simpler, so that's nice. But we'd rather not have to write this whole function 2 times, once for when we're going to be running on older CPUs and once we're going to be running on newer CPUs. It would be nice if we could write it just once. So what we can do is we can, up top, define SSE41 or not, right? And then we can check here and say if SSE41 is defined, then we can define blend as blend vps abc. And then if it's not defined, then we can define it as or and not and, right? The complicated mess that we used down here. Oh, we did let's see, this should be A, B, C, like that. Okay, so now we've defined the same blend conditionally, depending on whether we've built for SSE41 or not. All right, so now we can have a single code base something like that. And when we just flip this, now we get the SSE2 version that does the or and not. And if we flip that, then we get the SSE 4.1 version, and we don't have to change our code. So that's a little bit more useful case of a macro. And you can imagine if you had a lot of cases like this with your SIMD code where you wanted one version or the other. In that case, the macros can save you a lot of pain. And if you're using C++, you can do similar metaprogramming tricks with templates. All right. Any questions about any of this in chat? So next up, not sure yet, but next up we might do abstract syntax trees. Or we might do algebraic data types. All right, looks like no questions, so I'm going to sign off and get ready for the next episode. Thanks.